Okay, we're looking at trig identities here, and I've given you the two at the top that really are crucial for you to remember, and that is this one, sine squared plus cos squared is always 1. Alright, that comes from the unit circle. You can always look that up. And tan x equals sine x over cos x also comes from the unit circle. Again, you can look that up. Alright, so you've got those two, you need to remember them. Now then, when you get one of these prove it things, what the best way of doing it is to forget the one side and work on the other. So I'm going to basically leave that side alone, and I'm going to play with this side until I get the side I'm leaving alone. So let's have a look at this. We've got sine x cos x, okay, over 1 minus sine squared x. Now, if I rearrange this one here, okay, I get cos squared x equals 1 minus sine squared x. So could I just say, well, hold on, sine cos x is the same as cos squared x? Well, yes, I can. Now, cos squared x, right, if I just very quickly, oh, sorry, wrong one, there, I can cancel a cos with a cos, and I'm left with 2 sine x over cos x, and using the other one now, sine x over cos x gives me tan x, so I'm left with 2 tan x, and that's what I'm after. That's a pretty straightforward one, but it uses both the identities that you need to remember. So there you go. Ultimately, you will be using one or both of them in every single one of those. Okay, so that's what you've got to look out for. The second one, a little bit longer, okay, but we don't really want equations here where we've got sines and coses, okay, because they don't really work very nicely. So therefore, well, when I say don't work very nicely, you can't do them. So therefore, you need to get it into one, either sines or coses. Now, in this case, because we've got this bit here, okay, sine squared x, I know I can change that to 1 minus cos squared x. So my first thing to do is 1 minus cos squared x plus 2, oops, that's not very good, x, equals 7 cos, oops, x. Alright, multiply out and simplify. I end up, and get everything onto one side, I end up with this, 2 cos squared x plus 7 cos x, what is it, minus 4 equals 0. Now, this then factorises. We've got 2 cos x, and we've got cos x, and we're going to factorise this just like, now I used to do this by saying, well, let y equals cos x, and you get 2y squared plus 7y minus 4 equals 0, and it was more of a sort of a format I recognise, but you don't have to do that. Now, basically, I'm looking for two numbers, multiply to make minus 4 and add to make plus 7. So I reckon the 4 is going to go over there. It's going to be a positive. 2 times 4 gives me 8. Take away 1 is 7. So I've got my cos of x equals a half and negative 4. Now you'll notice straight away that this one can't be done. Okay, because you know that your cos x graph only goes up to 1 and down to minus 1, doesn't it? It looks something like this when, I'll draw it up here. Something like this goes from minus 1 to 1. Okay, so if it's at minus 4, okay, it's not going to cross. So there we go. Now I put that x equals cos to the minus 1, or shift cos, whatever you want to call it, of a half, and I get what is it, pi over 3, okay, and 5 pi over 3. Okay, again, you're working in radians because it says here, there's your clue, your 0 to 2 pi, alright, and you know that, what was it, cos of a half, so it's going to be there and there. You know halfway is pi. Alright, basically you've got to remember the shape of the cosine and the sine and the tangent graphs, alright, but ultimately it's not too bad. You just got to work through it stage at a time, Okay, it's easy to make mistakes yet again, so do set out your workings very, very clearly.